So here is the checklist for today's class. We're going to be looking at greenhouse effect and atmospheric pollution. So first of all, the greenhouse effect, this occurs when energy from the sun enters the Earth's atmosphere. Earth absorbs some of the heat and the light, and some is reflected back out into the atmosphere. Some of it escapes and is lost to outer space. However, some gases that are in the atmosphere they trap the heat and keep some of it in. This means that the atmosphere behaves like a greenhouse in the garden. It traps heat energy, keeping the inside warmer than what it would be without it. So the greenhouse effect, very important that you understand that it's a completely natural occurrence. This would have to happen all the time. It's confusing because in the media now, a lot of the time, it's made to sound like the greenhouse effect is a really bad thing. But in fact, if we didn't have this greenhouse effect occurring naturally, life on Earth couldn't be sustained because it would be too cold. And the reason this happens is that there are some gases in the atmosphere that are particularly good at absorbing the heat, and such gases are called greenhouse gases. So a greenhouse factor is a measure of the greenhouse effect caused by a gas relative to the same amount of carbon dioxide. Carbon dioxide is assigned a value of 1, and what that means is that every other gas is assigned a value based on its comparison with carbon dioxide. So for example, methane is 30. That means 1 molecule of methane has the same effect as 30 molecules of carbon dioxide. Methane is 30 times stronger as a greenhouse gas than carbon dioxide. Water vapor with a value of 0.1 is 10 times weaker than carbon dioxide as a greenhouse gas. And that's comparing 1 molecule to 1 molecule. We're not taking into account the quantity there are here. This is just taking into account 1 molecule of carbon dioxide compared to 1 molecule of the other gases. So if we're increasing the amount of these greenhouse gases, we may be causing the Earth to get warmer. This occurrence is the enhanced greenhouse effect, and if they were being totally correct in the media, they would be calling it the enhanced greenhouse effect. When they're discussing the negative impact we're having on the Earth. So the enhanced greenhouse effect is what's causing global warming. We are producing too much of these greenhouse gases, and that's causing the atmosphere to trap more heat, and it's causing the temperature of the Earth to increase. So you need to know the difference between these key words. Greenhouse effect, completely natural occurrence. We couldn't survive on Earth without it. The enhanced greenhouse effect is what's happening because there's too much of the greenhouse gases in the atmosphere. The greenhouse gases are the ones that trap the heat in the atmosphere, and global warming is what's happening as a result of the enhanced greenhouse effect. Carbon dioxide levels then, if we look here just at the difference between the year 1000 and the year 2000, we see a huge increase. They don't necessarily ask you about this, but just to point it out since it's kind of discussed in the book anyway, the reason for that difference as we approach the year 2000 was an increase in population, an increase in demand for cars and fuel and energy and all of that. If we look at the graph on the right, we're looking at, we're zoomed in a bit, we're looking at individual years. And what you can see when we're looking at that one is you can see the general trend overall is still that we're increasing the amount of carbon dioxide that is in the atmosphere. But you can see if you were to zoom in on 1 year, you can see there's this general trend within a year is the zigzag. And the reason for that is that in the spring and summer we have lots of plants, so there's lots of photosynthesis happening to use up carbon dioxide. And then we have that increase in carbon dioxide towards the winter because we have less plants, less carbon dioxide happening, and there is more plant decay. Residence time is the rate of turnover of a gas in the atmosphere. It says there carbon dioxide, but it's for all gases. The residence time for carbon dioxide is approximately 100 years, and what that means is that the average molecule of carbon dioxide remains there for about 100 years. The most efficient removal method is photosynthesis. However, photosynthesis can't keep up with the demand that we're creating by burning so many fossil fuels. Photosynthesis and respiration can cancel each other out. So if it was just plants and animals, we would hopefully be able to keep a consistent level of carbon dioxide, because they're, as we saw in the last lesson, their reactions are the opposite of each other, so they would balance each other out. But we are creating so much demand for the removal of carbon dioxide because we're producing so much of it. Eventually, all of this extra carbon dioxide that we are creating would be dissolved into the ocean. And how that happens, we spoke about it being dissolved as hydrogen carbonates and carbonates. Some of it is used for photosynthesis for plant material in the ocean. And then some of it, we said, can be transported to the bottom of the ocean where it can remain dissolved. It can also be precipitated down at the bottom of the ocean as calcium carbonate. However, before it can reach these depths to be precipitated or to remain dissolved down there as carbon dioxide, this takes hundreds of years. Because it takes a very long time for the surface water, the water that's at the surface of the ocean, to be mixed enough by currents that the molecules of carbon dioxide would travel to the bottom. So the next gas we're going to look at is water vapor. And this actually has the biggest impact on the greenhouse effect out of all of the gases. And the reason for that is due to its higher concentration. You can see in the first pie chart over here, the blue section is water vapor. The other gases that we're discussing here only make up about 5% of the atmosphere. So that's number one. You need to learn them off in this order. Number two that has an effect, the second biggest effect, I should say, sorry, is carbon dioxide. The third is methane. Fourth is dinitrogen oxide, also called nitrous oxide. And the fifth is CFCs. So that's the order in which they have the biggest impact. You'll notice that that doesn't agree with the greenhouse factor, because as we said earlier on, the greenhouse factor is comparing one molecule for one molecule. Here we are comparing that, but also incorporating in the concentration of the gas that's present in the atmosphere. So water vapor has the biggest impact and CFCs have the lowest impact. And again, just to point out, most of the atmosphere is made up of nitrogen and oxygen gases that we spoke about before. However, they are not greenhouse gases. So we are talking about all of these gases which are in that other 1%. So water vapor has a greater overall effect than carbon dioxide because of its concentration. However, human activity does not greatly affect the concentration of water vapor, which is a good thing. Water vapor concentrations depend on temperature, and they are controlled by the evaporation and condensation of water in the water cycle. CFCs are chlorofluorocarbons that we will see more of in the next chapter. They're present in very, very small quantities, but as you can see from their greenhouse factor, each individual molecule has a big effect. And the exact greenhouse factor depends on the specific molecule that you're talking about. We'll see more of those later on in the chapter. Dinitrogen oxide as well as CFCs both have a similar residence time to carbon dioxide. So they both would last in the atmosphere for about 100 years. Methane has a residence time of 10 years, so much shorter. And the reason for that is it can be broken down naturally in the atmosphere. So the causes of global warming that we need to look at are the ones that are based on human activity. So carbon dioxide, the reason that increases is due to burning of fossil fuels and deforestation. Methane, CH4, increases due to emissions from landfill sites and waste dumps, increased numbers of these animals, which are called ruminants, cattle, sheep, deer, giraffes, etc., and emissions from swamps, bogs, and paddy fields. The increased levels of CHCs in air are due to aerosol sprays and foams and discarded fridges. Rising levels of dinitrogen oxide are due to car exhaust fumes and nitrogenous fertilizers. The effects, these are summarized nicely, the three that you need to know are in bold here, and they're summarized nicely on page 98, so you can have a look through those yourself. How to control the greenhouse effect, or the enhanced greenhouse effect that we're creating. We can reduce, reuse, recycle, so we have fewer landfill sites and waste dumping. We can use renewable forms of energy to replace fossil fuels. We can find replacements for CFCs, and we can work on ways to dissolve more carbon dioxide in the oceans. The main things that we can be doing is reforestation, planting large areas of forest, and protecting the tropical rainforests that we do have. By cutting these down, we have less trees for photosynthesis, which is often accompanied by burning of large quantities of wood, which in turn produces more carbon dioxide. The next section is atmospheric pollution, and this happens when there are constituents in the air that are present to an extent that there is a significant hazard to the present or future health of a population or the environment. And the reason that this is occurring so rapidly is that we have a bigger population, so we have more people, more homes, more cars, more industries, more demands for energy, all of that, which all creates pollution. So the main thing we're looking at in this section is acid rain. Normal rainwater is already acidic. This is important. They do ask you about this already. Why is it acidic? And the reason for that is what we've seen with carbon dioxide. Carbon dioxide from the air can dissolve in the rainwater, forming carbonic acid. However, this is not something to be worried about. What we need to worry about is acid rain, which has a pH of between 2 and 5. And the main contributors to that are nitrogen oxides, specifically nitrogen monoxide and nitrogen dioxide here, and sulfur oxides, which are sulfur dioxide and sulfur trioxide. So NOx just stands for nitrogen bonded to different numbers of oxygens, and the same for sulfur. So sulfur dioxide is the main contributor to acid rain. There are some natural sources of it, like from volcanoes and rotting vegetation. However, 85% of the sulfur dioxide in Europe's atmosphere comes from burning fossil fuels, which have small amounts of sulfur in them. So when the fossil fuel is burnt, it creates sulfur dioxide, that blue equation. That sulfur dioxide then reacts with water to form sulfurous acid. That sulfurous acid then goes on to react with oxygen to form sulfuric acid, which is what comes down as within the acid rain. You need to know those equations, not the blue one, the other two. So you can learn those two off, or you can combine them. So you could also have sulfur dioxide plus water plus oxygen, giving you sulfuric acid. And to balance that, it will be sulfur dioxide plus water plus a half O2, because down here we're working with two sulfurous acids, where we're only after making one up here, would give me 1 H2SO4. So you do need to be able to write out the equations for that. Whichever way, if you learn it off, it might be easier to learn off the first one. If you try to understand it, it might be easier to do it in the two steps. The second way sulfur dioxide can cause acid rain is if the sulfur dioxide first reacts with oxygen and then that creates sulfur trioxide. The sulfur trioxide will then dissolve in water to form sulfuric acid. And we can again write that all as 1. So SO2 plus O2 plus H2O will give me H2SO4, and we would just need to balance that out with 2 waters there. So you need to know those equations. You can do it in the 2 steps, the green and the orange, or you can do it in 1 step that I've written out very messily there. The effect of sulfur dioxide on universal indicator. This is the exact same as in the section on carbon dioxide. You don't need to know the method, it's not a mandatory experiment, but you do need to know the result. So here what we've got is hydrochloric acid reacting with sodium sulfite, and that's producing sulfur dioxide. The sulfur dioxide gas is bubbled into the universal indicator. Because it's acidic, that causes the pH to lower, and so we get a color change from green, which would have been neutral for the universal indicator, to red. And again, the same kind of things we said for the carbon dioxide. The sulfur dioxide increases slowly, so you see a series of color changes from the green all the way through yellow and orange down to red. But all of the colours that you would see would be on the acidic side of the scale. The other way in which acid rain can be formed is from oxides of nitrogen. There are natural sources of these, like soil bacteria and lightning discharges, and there are man-made sources, which is burning of fossil fuels in power stations and in engines. This is at very high temperatures. So in a car, the fumes from the car exhaust produce nitrogen monoxide by that first equation and nitrogen dioxide by the second one. Then these gases react with rainwater to produce nitrous and nitric acid. And these are the acids that cause acid rain in relation to nitrogen. So just collating all the information together, this is just a table of the sources of pollution. You don't need to separate them out into domestic, industrial and internal combustion engine. You could state all of those together. They are technically the human made or the man-made. The harmful effects of acid rain then, it causes foliage damage to trees. It causes leaching of metal ions such as aluminium out of soil and into waterways, and this can lead to a lot of fish kills. It causes erosion of rocks and limestone buildings, and it accelerates the corrosion of metals. How to control acid rain would be to burn fewer fossil fuels, use alternative and more sustainable forms of energy. Make sure all cars are fitted with catalytic converters, as this will severely decrease the acid rain caused by nitrogen oxides. Use low sulfur fuels, plant more trees for reforestation, and the one in bold here is one that they specifically want you to know, and that is installing limestone scrubbers in chimneys to absorb gases. So sulfur dioxide that is burned or that is produced from burning fossil fuels combines with limestone to form calcium sulfite by this equation. The calcium sulfite then reacts with oxygen to form calcium sulfate, and this can be taken off and used to make plaster. So your checklist here is complete now, hopefully. If there are any questions that you have or anything here that you feel like you can't tick off that you need more clarity, note it down and give me a quick email to let me know.